Hello, greetings. This is Dr. Costa from costamedic.com. I'm a medical doctor and epidemiologist. Over the last 5 years, I have done data analysis for about 500 different medical research projects, and most of the data analysis I have done using Spss program. Therefore, I would like to start my own Spss video tutorial series. This is going to be on YouTube and it is completely free. The main purpose of this Spss video series is this video series is created for the beginners. So if you are complete beginner, if you do not know anything about biostatistics, medical research, data analysis and Spss, then this video series is going to be very helpful for you. If you have just installed Spss software in your PC and opened the Spss for the first time, then the first thing you will see is like this. This is the Spss statistics data editor window. In this window we have two types of views. One is data view, the current view, and another one is variable view. In the data view we will input data and modify data. In the variable view we can input variables and modify the variables. Now I will show you how to input data in the Spss data view. You can simply write your data here. For example, I am writing some gender data: male, female, female, male. Then I am writing their age: 55 years, 54 years, 44 years, 30 years. Please notice that the Spss have created two variables for our data, var00001 and var00002. These two variables are also visible in the variable views. The first variable, var00001, is a string variable because this contains text data, and the second one is a numeric variable because it have numeric data or numbers. I can easily rename these variables. The first variable is going to be gender. The second variable is going to be age. You can also copy the data from another software. In this example, I am using Excel. This is a large data set. I want to copy some marital status. Copy and then paste here, or Ctrl V. Now we have 3 variables and 4 cases in our Spss dummy data set. I am going to quickly rename the variable 3 marital underscore status. I have used underscore instead of space because this name column does not recognize space as a valid character. Now we have only 4 cases, and this little amount of data is obviously not good enough for any statistical analysis. So I am going to quickly input some more data here. I also want to input the marital status data here, but if I write here married, I cannot write the last letter, which is D, because the marital status column width is set to 6, which means the cells in this column can only have 6 characters at max. So I have changed it to 7. Now I can enter one more character, which is D. Now I have completed the data set and we have 20 cases. Many of the cases are single at middle ages. This obviously does not make any sense. The purpose of this dummy data is to understand statistical processes. We are not going to present these data to anybody. Now I will create another variable which will be the serial number. It is always a good practice to use a serial number or ID to identify each of the cases separately. We can easily rearrange any of the variables in ascending or descending order. If we want to check who is the youngest among these 20 cases, then I can easily right click here and sort ascending. This is showing now that this person is aged at 23 and she is the youngest but married. Now if I want to go to our original order, all I have to do is I can reorder the serial column in ascending order. If we did not create the serial number column, then we would have no option to go back to our original order. Now I would like to add another column to the dataset, which will be their job title. Let's assume all of them are academic persons, so they are either lecturers, assistant professors or professors. I am fast forwarding the repetitive tasks because I don't want to waste your time. I'm going to rename this variable as job underscore title. Now I will explain to you about these columns in the variable view. These columns represents different properties of each variable. But before explaining these columns, I am going to introduce you to our team. We are Costa Medic team. We are a team of medical doctors, epidemiologists, multimedia digital artists like animators and illustrators. Together we create high quality medical illustration, medical animation. We have data analysis and medical article writing services as well. You can find us in www.costamedic.com. We are also available in any major social media platforms. Now let's get back to the variable view. I am not going to explain everything in very detail because this video series is going to be for the beginners. The first column or name column is the column to write the name of each variables as we have done earlier. The second column is for variable types. We have different types of variables. For numeric data, in our dataset the age is the numeric data. We have selected the numeric variable type. For text data like marital status, we have selected the variable type string. We also have date variable type to input date data, dollar to input the dollar data, and custom currency to input the data for other currencies. The other variable types like comma, dot and restricted numeric, these are not commonly used, so you do not need to learn this for your basic data analysis skills. The next column is about the column width. It means how many characters each of the cell in the data view can have. For example, for marital status column, the width is 16. That means we can write maximum 16 characters in each cells in marital status column. The next one is decimal points. Here the age have 2 decimal points and we can see 2 numbers after each decimal points. If I make it 1, then there will be only 1 number after decimal point. Now we are going to make it 0. So there is no decimal points. The next one is the label. Here we can write some little descriptions or something more about the variable names. For example, for the age variable, I can write age in years, because age can also be calculated in months, so I have made it more specific. The next one is values column. Here we can assign a numeric custom value to any of the text based variables. For example, the job title, I can make all the lecturer 1, all the assistant professors 2, and all the professors 3. To do so, I am copying lecturer from here. For lecturer value, we will label it as 1. Then I am copying assistant professor, and again I am assigning another value which is 2 for the assistant professor. Lastly, I am copying the professor, and assigning a value which is 3. Now if I click on this button, then the respective values or codes are shown for each of the text based data. Again, if I click on this button, the respective texts are shown. The next one is missing column. The missing column identifies each of the missing variables. For example, if we have some missing data, for example, if this person is very shy about telling her age, maybe she did not give us any data. Same for this person also. Then we can let the SPSS know that we have some missing data. In the age column, we can add a discrete missing value which can be any number. In this case, I am going to put 999 because nobody will be 999 years old. Now I am putting this missing value here, and if I want to calculate the mean of all these age of all these cases, then I have to go to analysis, descriptive statistics, frequencies. I have to take the age in years variable into the right side. Then I have to select mean. OK. And the result in the SPSS output view is showing that the mean of all ages is 46.67 years. Please note that SPSS have used 18 cases to calculate this mean. SPSS did not use all 20 cases because we already let the SPSS know that 2 of our cases were missing. If SPSS used these 2 cases to calculate the mean value or mean age, then the result would have been wrong. So sometimes we have to let the SPSS know which one is a missing value. The next column is columns. It is unnecessary. It just shows how much the width of each column is. For example, the job title column is currently 8. So 8 characters are visible now. If I make it larger, it automatically increases in size. If I make it 8, then it goes back to the original size again. The align is self-explanatory. It shows the alignment of each of the variables. Currently, the serial, gender and age is aligned on the edges. So let's make this center aligned. Now the serial, gender and age columns are aligned at the center. The next column is measure column. It is very important to understand this column because this column represents the measurements of each of the variable. The gender variable is measured in nominal level, which means gender is a categorical variable, and in our case we have two attributes for this category. One is male and another is female. Marital status is exactly like this. So this categorical variable have two attributes, single and married, and marital status variable is also measured in nominal level. For categorical variables we can use nominal measurement. In contrast, for age data we can use scale measurement because age data is a numeric data and we can easily understand that this person is younger than this person. 30 is a lower number than 40. We can add these two numbers, we can subtract, we can multiply, we can make a ratio, we can divide these numbers, which we cannot do for categorical data. When we have numerical data which we can add, subtract, divide or make a ratio of, we denote this type of data as scale level data, and we will select scale from the measurement column for this type of variable. Another type of variable is ordinal variable. When the data is ordered, by ordered I mean for job title data, we can easily understand that assistant professor is a higher rank than lecturer and professor is the highest rank. It is higher than assistant professor. So we can understand who is ranked higher and who is ranked lower, but we cannot add, subtract, multiply or divide any of this variable as we can do for the age column. For this type of data we will use ordinal level of measurement. The last column here is the roll column. It is used to assign different roles for the variables. It is not so important for the beginners at this moment, so I am not going to talk about this. Now I am going to end the first video in this video series because we have learned a lot of things here. We have learned how to input data, how to create different variables, how to create missing values, how to assign specific codes for each of the text-based variables, and we have also explained you all the properties for each of the variables. In the subsequent videos I will tell you how to do specific statistical tests like t-test, ANOVA, chi-square test, etc. I will make the next videos if I get good amount of support from you, because if you don't even watch this video, like this video or subscribe to my YouTube channel, then there is no point of making these videos. So please subscribe to me and hit the bell icon so that when I create the next video you can get the notification. Thank you for watching my video. Stay healthy, stay safe.